camera on my computer, and that's for your pleasure, so you don't have to look at my ugly mug. And the first one I'm talking about is the QHY 174M-GPS camera that we used for the MU-69 occultations in Argentina and South Africa this past summer. Several of us, I think maybe up to 5 or 6 now, IOTA members have these cameras. I just purchased my second one last week and haven't even had a chance to turn it on yet. I just got back from vacation. So I guess, Ted, you're controlling it. Can you go to the next slide, please?
What do you want to go, like at 6? Is that too late? Or
okay, so this camera started being sold around December or January this year. When they first came out, Bruce Hollenstein and I each purchased one as soon as it became available. And after very limited testing, it was selected to be used on the occultation campaign this past summer by SWIRI. And in support of that, SWIRI purchased 22 of these cameras, matched to 22 of the Skywatcher 16-inch telescopes. And as I said, since then, several other members I know have purchased this camera, and I just got my second one specifically for the Triton event for something I want to do there, which I'll actually talk about in the next presentation. Next slide, please. So here's some photos of the camera. This is, compared to your run cam, this is the complete other direction. So this camera is about 2.5 inches in diameter. It's about 3 or so inches long. Has a large chip in it, which I'll give you the dimensions in a slide or two. So the left image is showing you the input end of the camera. And I have an inset there showing you it's a very rectangular, I think it's a 9x16 or something like that array in it, and it is CMOS, as Tony alluded to earlier. And then the right picture is the back where the connections are made. There's a connection for the GPS antenna and the USB 3 port. And they're the 2 required connections. There's also a cooler, so you can cool the camera down, but you don't have to do that to run it. So if you're doing a short exposure time, you don't have to bother with the 12-volt in for the camera. You can also control a filter wheel, because this camera is intended for other purposes, not just occultations. And it also has a guide port built into it. And I have not touched either of those two, neither the filter wheel nor the auto guide port, so I have no idea how well they function or don't function. Next. Chris, yeah, that's interesting. Chris asked the question about his 174 will not run without the 12-volt input. And I've had all sorts of bizarre results initially with mine that I attributed to not having an adequate 12-volt power supply, and then I removed it, and mine seems to work. So other people have told me that theirs don't work, so I don't really understand if there's a difference in the firmware. But like I said, some seem to work and some don't without the 12-volt. When we were down in Argentina and I assume South Africa, we always were running them with the 12 volts attached and at some nominal level of cooling. I think we were running 0 if I remember right, but maybe one of the other guys from Argentina can remind me on that. Anyway, for comparison, the current high-end camera is the Wattec 910 series, which I think I got mine in December of last year for about $600. I had been using old Steadicams up to then, and going to the 910 was just a huge difference, and immediately displaced by Steadicams at that time. So I'm going to use the 910 as comparison on the following charts to the QHY. Can we go to the next slide? Okay, Okay, so the 910s, to my knowledge, are CCDs. This QHY is a CMOS. The pixel size is somewhat smaller, at almost 6 microns square. Has a lot more pixels, so you end up with a significantly larger array size. And I put down what the field of view is for several different combinations of telescopes. You know, the ubiquitous C8 with a 0.5 reducer. You end up with almost a third of a degree field in the long dimension. And that would allow you to get an untracked target drifting through your field, lasting almost 3 minutes if you go diagonally. Since I have a C14, I put down what C14 can do. You can see with my Hyperstar installed, I get almost a degree in the long dimension, which is very nice and large. I really enjoy having the extra field of view. It's going to allow me to do things like leave my home observatory unattended with a higher confidence. You know, I have a C14, but I have a rather overmatched CGE mount that tracks fine for reasonable amounts of time, but if I want to leave it unattended and go to my other county nature center observatory that I run, I can do that with more confidence with larger field of view like this. Next slide. Okay, so the 910, of course, has composite video output, and the 174 uses USB 3. I have not myself tested if it works with USB 2, so if someone else has, maybe they can chime in on that. The full frame rate, of course, with 910s is 30 hertz, and what I can get out of my QHY with my old Toughbook, actually the one I'm speaking to you on right now, with many dropped frames, I will even add, is 40 hertz. The manufacturer claims that if you go to 12 bits, you can run over 140 hertz. And I have not tried to do that yet. If I had a better computer, I probably would. It's heavy. It's almost a pound in comparison to the 910 at, what's that, a couple of ounces, and then the run cam at a fraction of an ounce. The threads are completely different. So you guys are typically used to using either C or CS mount threads. This has an M42, which I think is a T2, if I remember right. And the data coming out, typically you save the 910 as an AVI. Here, with the software we have, you can save it as a SER file, an SER, which is a compressed file, I believe, with more than 12 bits, but we typically run these in FITS format, so we're just generating a series of FITS images at 12-bit depth. And you can also save them as an AVI file at 8 bits if you want to. Next slide. Okay, for a price comparison, I tried to add up a complete system for the 910 and what you do to get a complete system with the 174. The one cheating thing I did was I assumed you already had a laptop available that had USB 3 in it. And you can see there's almost a $400 price difference to go to the QHY camera. And as I said with mine, I don't think you generally need to have power, the 12-volt power available, but maybe on some of them you do and some you don't. Next slide. So this camera is significantly more expensive than the current high-end camera, but it does have a significantly larger field, and for what I'm doing, I think that's useful. I don't know if that applies to everybody else or anybody else. And it probably has a lot more non-occultation utility than video options. Like if you're into planetary photography or moderate, I guess this is considered to be a small field camera now, but you can do, faint fuzzy photography if you want to with this camera as well. So if you're looking for, an all-in-one and you're doing more than just occultation timing, it might be worth considering from that point of view. Next slide.
Everybody's laughing about drinking. Nobody's drinking.
Okay, so issues to date we've had with this camera, and there have been a moderate amount. The initial cameras we received, both Bruce's and mine, had the problem that Histro described when I first mentioned that I was thinking about getting one, and that is you couldn't get GPS data in 12-bit mode. When I went to buy my camera, I specifically asked the reseller, I guess, which was Astrofactors down in Texas, if this had been corrected. And they went to the manufacturer, and the manufacturer said it had been corrected. And it turned out it hadn't. So when I got mine and found this out, they ended up having to send me a kit to upgrade my FPGA and the firmware to do that, and I ended up uploading it myself. It wasn't really hard to do, but to get under the hood, to pull the back out, you have to worry about like the GPS wire and things of that sort. And I believe all the later ones this had been corrected on, but that was a kind of a surprise. Let's see, and then the USB connector on the back of the camera. We had a lot of problems with these down in Argentina with the connection being somewhat flaky. I have not had that happen on my own camera, but there were several, including one of the ones I was using down in Argentina, that had that problem. The cigarette power adapter that came with the camera doesn't fit some power outlets on the cigarette lighter side. And last, this is one that really annoys me, is the M42 threads are not cut very deep. And if you try to mate it to a set of male threads that are also not complete, you can go all the way through and you end up with a loose fit. And that is quite annoying to deal with. Tony made the comment, the double-edged sword on a larger field, and that's true, but you can also run this in window mode if you want a smaller field and run faster. Next slide. The other issue is focal reducers, and to date we really have not found an optimal focal reducer solution for these cameras. The inexpensive focal reducers just aren't well corrected over the size of the array. The best behave of the 2 or 3 I purchased so far is an Antares 0.5 2-inch format focal reducer that Scope Stuff sells. You can buy that with the adapter you need for about $52 from them. But you're still, I think, going to be a little bit disappointed with what your images look like in the corners. Next. Okay, timing testing. I've tested mine somewhat with the Sexta unit that Bob Allberger fabricated for us last year. I put a C-mount COTS camera on the front using a Scope Stuff T2C adapter. Always waited for the QHY to download the almanac from the GPS, and I collected the data at 12-bit FITS files, even though, of course, there are really only 8 bits of data there, or 12 bits of data there. Next. Here's what I'm seeing for the measured delay. Exposure time is on the x-axis in milliseconds, and then the delay I'm seeing is on the y-axis, also in milliseconds. And as soon as I get up to exposures an eighth of a second or longer, the delay time is smaller than my ability to measure it, which for the shorter exposures is a couple of thousandths of a second with the Sexta. The interesting thing, and this makes me wonder, Tony, if you could be right about the rolling shutter thing, is at the shorter exposures, you can see that there is a significant exposure delay I'm measuring. So I will now go back and look at my data and see if a rolling shutter could explain it, and that should be really pretty easy to pick out of my data.
Well, you're talking to me. I can't hear, Cindy.
Okay, next slide,
You
please.
have to hear what you said, because I don't know if it's important or not.
So I have a ton of unanalyzed data that I took. I had to take a bunch of data before I sent my sexta out to Mark Bowie. He's going to be testing a subset or maybe all of the cameras that they have. I only measured on a single camera, and this was the camera I had that I reloaded the FPGA on. And the other interesting thing is that the breakdown in when it does have a delay time is exactly when the camera duty cycle moves meaningfully away from a duty cycle of 1. And all the testing I did was with the USB traffic setting set to 50. If I had reset it to a lower setting, which I found out if I reset it to 0 or 1 or something like that, I got a much better frame rate. Yeah, I will look at and see if that matches what my data shows, Tony. Next slide. Also looked at the exposure time versus commanded, and it was correct to my ability to measure it, which is an order of 2 milliseconds. I have a bunch of on-sky data that I can use to measure the signal to noise on sky to compare to the LaTeX 910. I have not looked at that other than a single data point, since in the spring we were really concentrating on comparing the 910s to the Malin cams to possibly go to Argentina and South Africa. The single point I have of apples-to-apples data I found in my notebook showed that the QHY may have a very slightly better signal-to-noise ratio for a Mag-14 star at half a second. I would not take that one to the bank yet by any stretch. Next slide. Another data point we have is there was an occultation in June that David and Joan brought their Skywatcher 16-inch up, and we put my QHY camera on that telescope, and right next to it I had my C9.25 with a LaTeX 910 and a VTI. Were right next to each other, and the data were fairly well matched from those two positives we had. Next slide. As far as software goes, to my knowledge, the only available freeware that currently supports this camera's GPS features is SharpCap. Mark Bowie's been working with the author to improve that software. It seems to me reasonably easy to use. I had never really used it before starting to use it with this camera. We did find down in Argentina that the reported latitudes in the FITS headers, the file headers, were wrong at times, and Bob Anderson diagnosed that they were dropping, I think, the 100th digit of the latitude, and that's been reported to the SharpCap author, and hopefully that will be corrected if it hasn't by now. Next. This is just a picture of what the software looks like. It has controls down the right side of the screen, and pretty much you can adjust anything you need to on this camera with that software. Next slide. So the big thing I think we're missing right now is we don't have a way that I'm aware of to preset recording for unattended operation. There's Python scripting you can do that we think will allow us to do this. Hopefully somebody will write it, and if not, I have an intern starting for me in a week or so, and I'm going to get the intern to learn Python, and we'll make him do it. Yes, that's right, Ted. The saving profiles, that is a big deal. So once you get it set up, like for occultation timing, if there's a settings you want to use, like the amp setting and all, we discovered you don't want to set the amp setting over 30, for example. You can set all that up, save that profile, and then next time you use it, you just reload the profile, and you'll have everything in place. Next. So for data extraction, Tangra seems to be able to handle the generated FITS files, very similar to using Tangra for AVI files. And I haven't tried it yet, but I believe ImageJ can also, or Astro ImageJ can also do this. Yeah, Chris is right. There are a few settings that aren't saved, and you can also get burned by if you leave the is it the file type? If you leave it in auto, it'll switch it back out of FITS. I think that was the one that just drives me crazy. So yeah, the software does have some idiosyncrasies still. Next slide. So as I said, I just received my second camera, and there's several of us, John, Bruce, and Bill. I guess Chris has one now too, and I think there may be one other person. So it'll be interesting to start comparing notes and finding out what else we find, what other warts we find as we use this camera more. Yeah, I've downloaded that FITS to AVI conversion freeware, and that does work well too, Tony. Next slide, or is this the last? Yeah, okay, so I like this camera, but honestly I wouldn't be recommending it to people starting out. Certainly going down your $170 one cam path is a much better way to go for a beginner in occultation timing. And we do need to do a lot more testing on this camera before we can have a lot more confidence in it. My big worry, though, is how long is this camera going to be around? Is there really enough market for a $1,200 occultation camera? You know, that costs $300 or $400 more than the non-GPS timing camera of the same type. So it really wouldn't surprise me if in a couple of years we didn't have this option anymore. I hope that's not true, and I hope it all works out, but we'll see. I think that's the last one. Let's see, have I compared the sensitivity at the same time of exposure? So you mean taking pictures from two different telescopes side by side at the same time? No, I have not been able to do that. I don't have I don't have a pair of telescopes to be able to do that. So I have to switch back and forth. All the data I took that I need to analyze yet, I would start with one camera, go to the other, and then go back to the first. So I bracketed it that way. Anything else?
Oof, that girl's good looking.
Yep, that's great, Tony. I look forward to that, and I look forward to seeing Mark Bowie's data that he takes, because he'll have a large sample of cameras. And I'm not sure, you know, what versions of firmware are on the various cameras out there.